not very good at it. Yeah, okay. So the second lecture is on scientific conduct, and ethics is on scientific misconduct. Misconduct would include the following things: plagiarism,抄襲. Second, experimental design fault, 實驗設計錯誤, including if you are doing a survey, bias sampling. This is quite often, you know, students like to. I still remember the EIA lab. Students are required to do a survey, right? And then they usually do it on their Facebook. And then they figure out most of the Facebook friends are also environmentalists. Okay, so that could be a bias. 4, falsifying data, basically making up data. Okay, and then again, we use the first week's discussion on the code of conduct. So what kind of code of conduct we should observe? But I would like you to rethink how this could happen, or alternatively, how are we going to avoid this to happen? Now, I think it's a mechanism there. At the end in the discussions, after the lecture, we have some topics for discussion. I hope to find rules or guidelines to make sure that the researchers would not do such misconduct. Okay, otherwise you probably would have done so without realizing that it's a mistake. Okay, so yeah. Like for example, I'm asking you to do the 4 domain survey and also the questionnaires, not the questionnaire, but the MCQs online. Those are the basic requirements for all researchers in CUHK. If we like to apply for research grants, we have to obtain those certificates. Okay, so that's one of the ways to avoid any wrongdoing. All right. So plagiarism. What's plagiarism? Number 1, it's an act of thief. So it's actually 盜竊行為. You know what's a thief, right? Something that you don't own it, and then you taken it from someone else. Okay? So it's an act of thief. Could be very serious. Could lock you up like this. All right. So, what kind of act that we are talking about? You're stealing someone else's idea. Now, of course, this is very controversial. So I still remember the iGEM team said, "Oh, this is my idea." So, and then other teammates think, "Oh, this is also my idea." I also came up. By the time, without saying my idea, you have already voiced out, right? So sometimes could be controversial, but taking someone's idea or work or writing is your own work. So if you learn some good idea at the same time, you should voice it out as well. Otherwise, you're too late. Especially if you want to apply for a patent. You申請專利咁大件事. Oh, that's already been filed in. Somebody else already filed in. And then the third case is also quite common in the academic world. Very common. Even a supervisor, say like for example, I supervise MSc research or MPhil or PhD research. Even a supervisor cannot take the students' work. If I take my students' work without informing them, and then I use it assuming that's my own work, that is also plagiarism. Okay? Some supervisors, they are very nice. They, "Oh, you just publish the data. You don't even need to use my name." In any case, if that research work is done in a lab, then the lab supervisor should be informed, right? Because this whole research is done in my lab, so I should be informed exactly what you have done in my lab. So we usually like to compromise, you know, who's the first order, who's the corresponding order. So authorship is also an issue here, but in this case here, we have seen many academics got complained. Okay, even my master student, I could not use their paper and then pretend those are my own work and publish. I still remember a few years ago we did some policy research, and then that is what 4000. Now it's called LSCI 4000. That's the literature review. I asked my student to do many policy research. We ended up publishing a paper. Actually, we used an abstract and published in Sunbo, Hong Kong Economic Journal, with not just my own name but my student's name as well. So usually you will see all the names appear together. If I only use my name, then I'm actually plagiarizing my students' work, and that is unethical. Okay, so you have to observe this. Number 4, citation and quotation. And sometimes you say, oh, I cannot find out. Oh, that is your problem, and you have to find out who actually was the one who said so, or who makes such claim, or who makes such comments. Okay, because after all, you have to do a citation or reference. You have to do this properly. And number 5, we call this paraphrasing and derivative work. That is also quite common. Oh, I just cut and paste, and one of the new requirements now we have for LSCI 4000 is that you are not supposed to just cut and paste any diagram from Googling, right? After you Google a term, then you can find a diagram. And oh, I just cut and paste, I could usually figure out it's not your own drawing. We usually ask the students to do your own figure, your own table. And then one of the tricky things is the gel data. Oh, this is a gel photo. How can I redraw and redo a gel photo? Well, that could be excused, but you have to say it's adapted from whom, or modified from whom. You can modify it, right? Paraphrasing. You know, sometimes it's called 以词創作. You modify it from someone else, and then you have to say, I modified from him or her, or from that particular source or reference. Okay, so we have to avoid that. In Chinese U, of course, we were so good that the IT guy, they developed this Very Guide around 10 years ago. And nowadays, of course, Very Guide is available for many different universities. All local institutions are using Very Guide. You don't need my explanation. How many of you have not done so? Most people hate this, right? But then you have to submit it. After the submission, you see to check out the results, okay, and making sure that there's no plagiarized material. That is to uphold and promote academic integrity and honesty. But how are we going to avoid these things to happen? There are some common mistakes that we could make. Number 1, quite common. Even I have this problem. Self-plagiarism. So I was complaining a recent paper that I sent to a journal. You say, hey, Dr. Chan, I found 10% of your paper got plagiarized material, and then I checked it out. It was actually my previous publication in an abstract. So I had to rewrite the abstract. So I have to, okay, and then I went to sleep. And then woke up the next morning and rewrite it. It's that simple. Sometimes I make such mistakes. Because now the internet world is so easy to search and find and match with information, right? So no matter what you put down, I just click, cut and paste, and then I could figure out who else are using or saying the same thing. All right, but self-plagiarism is also a problem. Number 1, previous work published, and then you don't cite it. Like we usually do that, quite common that we make such kind of mistake in the abstract and also in the materials and method. The materials and method is always okay. 5 animals were treated blah, 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 for how many days, and then the assay, the enzyme assay or real-time PCR was performed more or less the same, right? Then you have to be able to tell exactly what you have done. But we usually would like to put down, okay, the protocol was divided or modified from, I usually use my own previous students' paper, Zhao and Chen, 2005, that's the original research, that the first time we published that method. Even so, sometimes it's hard to avoid, and then what you can do is to put all this information aside and then from your own brain and do your own typing. And second thing, assuming there's new information, but actually it's not new information. Now, this is quite common for students. We have heard a lot of complaints. I've seen many of these, especially from my GE courses. Some students did similar survey when they were high school, when they did their high school projects. Quite common in environmental survey. Oh, they're more or less the same, right? Household charging scheme, household waste charging scheme, or plastic waste. Some students actually, forgot to do my science fair project and it's due tomorrow, so I just used my previous project and put it in another competition or hand in as a report, okay? Yeah, maybe I could just reuse last year's, and that's not acceptable, okay? Finally, these are also common mistakes, not just in Hong Kong, but around the world. I suppose mainly in China. Publishing the same materials in different languages. There were a few cases in Baptist U, they were found that they published the same data in Chinese journal, okay? And then we wrote into English journal article and submit to. I've been involved in the editorial board of at least 2 or 3 journals. Why they need us? Because my friend in California, Dan, is in UC Riverside, Department of Environmental Science. Hey King, you better do this job for us. You read Chinese. Help me to search this Man Feng so good. Okay, all Chinese journals could be found there. As an editor, your first job is to click and search for any violation of plagiarism, including publishing the same materials or information in different languages. Okay, so of course nowadays there are many Chinese journal papers are also in the SCI public domain. Okay, and the abstract is English. Okay, even the article is in Chinese, but the abstract is in English. So it's quite easy for the international or scientific community to search whether those data have been published before. Okay, so that is how to avoid self-plagiarism. Finally, this is also important. Redundant publication. I don't know. I've been in the field for long enough. 30 years, some scientists, I keep saying, how come this guy is still working on this kind of project? Sounds like a very old topic, waste recycling. Oh, just using a different organism to study. All right, the evolution of intellectual freedom. And then become a grad student, become a professor, and then retire. And then in the entire life, probably still working on the same thing. You see, because this is a very important piece of work. But then redundant publication is also what we call dishonest. And then this one is also highlighted. You publish, I would do whatever I can do if I can get the money to do it. You see what I mean? That is the publish for the sake of the granting committee. The granting committee want me to do this, I will produce this result to satisfy. Because that will guarantee I can get the research grant, right? there's also a kind of dishonest. I don't know. Sometimes I have hesitation to apply for those Environment Conservation Fund, ECF, and then sometimes it's not easy as a researcher. If you want to get that kind of money, so I would say there would be some sort of what we call censorship. But still, if you think that you're publishing for the sake of the granting committee or the service organization, like for example, I'm doing a survey for the third runway, going to do a dolphin survey again. Okay, so you have to stand up for yourself. Okay, what kind of research or what kind of quality of the research that I have to do it right, right? So if you do it just for the sake of that organization, it's also dishonest. In any case, many publications involving in, like for my research field as a toxicologist, Society of Toxicology, we study the toxicity of chemicals, or many drug companies, toxicology and pharmacology journals. The basic requirement is that you have to declare interest. We usually say, like, this research is not funded by any drug company, or this research is not funded by any chemical company, right? We are not saying that you cannot accept drug company or any chemical company's sponsor, but you have to declare interest, all right? So like this is a headache drug or stomach drug. I accept the money and then I prove that this drug works like a charm. But then you have to declare it. I got this money from this company and I'm performing the research to prove that this chemical is safe or to prove that this drug is safe. Right, so these are the basic requirements that you have to do, or I have to remind you to do. Okay, we go on to the second topic, is on experimental design for. And I used an example in last lecture, but no one liked to discuss it. How are you going to sample tear gas, damage or toxic effects or persistence of tear gas? Okay, I just got a call from RTHK. The reporter asked me how to do it. I said, I'm not doing it. I don't know how to do it. And then he asked me to comment on someone else who did that. I said, I don't have any comment. I don't comment on somebody else's research work, openly at least. But then you have to be very careful of what kind of research are you going to do and the purpose of the research. And then you have to pay attention to the potential errors. And then the first thing I said to them, okay, you want to study tear gas. Everybody knows what is tear gas, right? There are different chemicals in it. And then in this case, they only analyze one chemical and never mention the other chemicals. So that's fine. But then because it's a dispersal of the chemicals in the air, right? So you're supposed to collect air samples, right? I made the same mistake when I studied air pollution the old days. Some scientists also did the same thing. Like, for example, just for convenience, I collect the dust from the ground because I could not go back to the site to collect the air samples, right? Do you think those data could be useful or could be used? Right? And then people could not determine the toxic effects of these chemicals on animals. Like we involved in the study of landfill site. And then what you can do is that you could find those animals on site and collect samples, right? Or alternatively, you take the animals and do on-site study. I put different rats and then put it on site. I mean, when you do those studies, there are standard protocols that you have to observe. Otherwise, you may get yourself involved into the errors by random error or systematic error or bias that you could have put yourself in a position to collect the wrong samples. And then to study air pollution, I still remember around 15 years ago, some scientists used pigeon. You know what's pigeon, right? Bakang. To study the impact of air pollution on different kinds of animals. They did find some useful biomarker and demonstrating some carcinogenic effects and so on. Okay. But then at the end, you cannot say these are the findings that could be extrapolated or can be extended to human beings, right? So if you really want to make a conclusion, okay, you have to ask yourself the justification and also the purpose or the hypothesis that you are going to test. Ultimately, if you want to do toxic effects of tear gas or whatsoever, you have to go to the hospital, right? Same thing is true for those who would like to study toxic effects of air pollutants. They obtain clinical data, right, from hospitals. At the Hong Kong U or CHK scientists of environmental health, they did collect a lot of data from hospitals. Of course, you may say, okay, those data could only find the correlation between air pollution data or index and those patients admitted in the hospitals. They have a lot of those data and did the calculation. Already found, like those been found in different countries, right? Different kinds of pollutants, one by one, carbon monoxide or particulates or SO2 and so on, could cause significant impact on human health, because when those figures were high, they observed more number of incidents of patients going into the emergency ward. And many of them are correlated with what they call the respiratory symptoms or even cardiovascular diseases. You know. And you say, okay, there are strong evidence. And then later on, you have to do experiments, of course not on human being, but to use animal models to do the test. Sampling errors include how to do it in a valid form, or how precise are you going to collect. And again, other than bias of sampling, you have to do what we call breach of duty of care, or not to do so, not to do it. Like, for example, you cannot disclose information without permission. And I'm involved in a study on microplastic. We study sewage. Now, major stumbling block is that I wrote a letter to the drainage department and asked for their permission to let me disclose the data. Okay, I've been waiting for months. I'm still waiting. So I will go back and ask them again next week. But I cannot disclose the information without permission. Now that's rule number one, right? Including some other patients' data. If you want to collect clinical data, you have to ask the patient to sign a form, right? One of the criteria that you would ask is that, may I use the data? If they say no, you have to ask for my permission. Then you have to ask for their permission. Right? Number two, you have to collect data from people not knowing the information will be used for research. Now that is also a breach of duty of care. Because the time you collect the data, they did not notice, or even now they do not know exactly what you are going to use with the data you collect from them. So that's also, you have to be very careful. And then not following legal needs to protect the subject to be studied, then you have to follow all those steps and procedures. So most of the time doing clinical studies could be quite difficult. All right, so you would again get more information when you do the website online MCQ. And then, of course, rule number one, if you want to study animal experimentation, you have to obtain an approval. Without the approval, you cannot do any experiments. So like in my lab, at the door, I put all those approval forms printed out clearly, demonstrating that I could do those experiments. Even so, if you change the protocol, you have to ask for further permission. Like for example, I only obtained the approval for acute tests. Acute tests mean short-term tests. Now I'm changing the procedure to do a long-term test. Right? Obviously, it's quite different, so I have to write again and ask for permission. And failure to meet with standard like infringement of copyright and so on, and other legal or ethical or professional obligation, this is also another form of breach of duty of care. Okay? So we have to be very careful on these issues. And yeah, let's take a break and then we come back on more discussion of biased sampling.